Hey everyone, we are going to take a little look at the concept of vibe coding today, and we're going to do it using one of my personally favorite subject matters, which is the NFL, specifically using it to predict the outcome of NFL football games. Now, we've seen probably a ton of news about companies like Lovable or Replit, and just being able to type a prompt, click a button, all of a sudden you had an app. It works. Apparently, you have all of these different demos coming from OpenAI, like when GPT-5 was released, where you just say, "Hey, I want a video game," and you get a video game, and it always demos really nice. And so, I'm always a little bit more skeptical on how quickly you can do that. I'm a firm believer that you can't really replace the hard work and the domain understanding of what you're trying to build if you actually want it to be more than just a surface level kind of situation. But that doesn't stop me from trying because I always want to keep pushing the boundaries and understanding what is the level of detail, what's the best way to interact with some of these new technologies come to market. And so I tried to vibe code an NFL game simulator when Sonnet 4.5 came out. And as you can tell, um, it looks nice. It looks like your typical Claude app, but basically, we're just going to go through here and upload a CSV file. Effectively, there's a whole GitHub repository that has detailed play-by-play data of every single play that happens in every single game. So it gives you a lot more flexibility to actually kind of understand game script, team personalities, etc. Um, you might look at a team and say, oh, they win on average by 4 points, and then the other team loses on average by 4 points. So therefore, we should expect that the first team should win on average by 8 points. That obviously isn't always the case. You're going to have fluky situations like the Eagles game when they played the Rams and they were winning by one. The Rams were about to kick a field goal to win, and then Philadelphia returned it, blocked the kick, returned it for a touchdown, ended up winning the game by 7 points. Um, that obviously is a situation that theoretically should have no predictive merit when it comes to the output because those types of plays happen so rarely. And really it should just be kind of captured in like the random noise of a simulation. And so the goal of a simulator based prediction method would ideally just be to kind of take those personalities, take all the randomness that happens in a game, and then run a whole bunch of simulations to actually figure out what are the probabilities of a team beating crossing a particular threshold based on how they would actually play. And so in this case, I have used a little bit of a delayed source, but the concept was simple. I was just like, here's the CSV of all the play data. You're an expert uh, in NFL games. You are going to build a simulator that simulates an NFL game perfectly, and you're going to use the most relevant stats in this giant spreadsheet to determine how successful plays will be, drives will be, etc. And so initially we just started on simulating the game and then run 1,000 sims. And at first I was super optimistic. So let's take today, which who actually plays today? It's like NFL game today. Yeah. Oh yeah, Steelers and Bengals. I was thinking the Browns for some reason. So in this case, we would take Pittsburgh, set them to the away team, and we would take Cincinnati, we set them to the home team. You click simulate game, and sure enough, like 17 drives, maybe a little light, but you look at it and it's like, oh, this actually seems like pretty decent. Like coding might work. Like this looks great. Cincinnati started on their own 25, very logical. Had an incomplete pass, a 9 yard run, so now it's 3rd and 1. Math checks out. Incomplete pass, so then they decide to punt it, and there's a 4 yard return. Surface level, that drive looks incredible. Like that looks very realistic. Vibe coding works. Well, not necessarily true, as we'll come to find out. Pittsburgh, similar situation, like a 3 and out, not great. These aren't the best of offenses. I think Aaron Rodgers is washed, and Cincinnati's obviously have a whole host of issues since Burrow's been injured, so nothing too crazy, right? Then here we have a successful drive. Looks like, yeah, so they punted 54 yards. There's a 5 yard return. So actually, that match checks out. Own 31. Now they're at their 20. And then they, yeah, a nice drive. Ran 5 yards, complete pass for 6 yards, ran for 5 yards, or passed another one for 5 yards, 12 yard rush, 0-yard pass, 2-yard pass, 10-yard pass, 4-yard pass. And then they had negative yardage on this run, incomplete pass on 3rd down. Okay, they have to kick a field goal. It even has a nice little sexy UI. I didn't have to tell it to do any of these things. However, where things really start to break down, though, is yes, things on the surface can look really successful. And so this is, I think, the real value proposition of vibe coding, so to speak, is I could probably take this to someone who's a football enthusiast and just give them this brief abbreviated demo, show them that just by providing a simple prompt and an Excel spreadsheet, it was able to create very realistic looking drives and simulate a game. And they might get really excited. So still has plenty of merit, obviously, and that's why I think we're seeing a lot of tools like Lovable being so successful, is if you just want to create a prototype to get some audience feedback, understand if whatever you're trying to build has product market fit, or just generate enough excitement to get confidence in whoever owns the budget to give you money to do something a little bit more involved, then vibe coding probably makes a lot of sense. But when you start to dive into using this tool en masse, a lot of flaws start to emerge. So we're going to reset this, and now we're going to run 1,000 simulations. So in this case, let's actually look at the spread. So we say Pittsburgh spread against Cincinnati. So this is going to be right. That sounds right. 5.5 points. Okay, so we go over here. We set Pittsburgh to be 5.5 point favorites. We run 1,000 sims. It does some general classification. So here we can see that the offensive expected points above profile for Pittsburgh, they're one of the worst teams at passing based on expected points above average per play, and they're one of the worst teams rushing. So we rank all these into effectively tertiles. I did tell it to do this at a certain point. It didn't automatically do this. So this was after a couple little prompts. I got so close. I was actually very tempted into thinking that this might work overall. Same thing for Cincinnati. They're both bottom tier passing and rushing teams. And then we can evaluate their defenses. So in this case, Pittsburgh profiles as a really weak passing offense, middle of the road rushing defense, and then Cincinnati sucks against the pass, and they're actually elite against the run. So then based on these, it simulated all these different drives for all these different games, and it's essentially saying, of all the simulations that were run, 59.4% of the time the Pittsburgh or Cincinnati actually won the game, and 35.2% of the time Pittsburgh did. So obviously we're not factoring in overtime rules here. That'll need to be something that gets accounted for later. And then we have how likely they are then to cover. So essentially, how many of these simulations did Cincinnati lose by less than 5.5 points? And in this case, we had 79.3. So you would say, okay, I'm going to go pull up BetMGM or DraftKings, FanDuel, whatever it is, and I'm going to go place a bet on Cincinnati. And that might be a good call, but then we start looking further down and we start seeing some cracks and some flaws. So look at the average scores of these outcomes. 19.7 to 16 is the average one. Rushing yards look a decent amount in line. Pass plays and run plays are eerily similar. That's actually a little creepy. Makes me think there could be some noise going on there. We can look at their average yards per rush, the average yards per pass attempt, catch completion rates. Drives are relatively in line. These aren't too bad. The average team has roughly the 22, I think, total drives in a game typically. And then total plays, this is where things get a little low. This is way too low. Only 56 plays for Pittsburgh and 63 for Cincinnati. And then we can look at the field goals. We can look at the red zone rates. And we start seeing that some of these are actually really, really small. And so ultimately, I would not trust this. And let's take example of teams we know have really bad defenses and really good offenses, just to further highlight this point. So let's take a team like Dallas, and let's then have them go up against the Chicago Bears. And we'll go ahead and run 1,000 simulations. So actually, Chicago's not that good of an offense, but they have a terrible defense. So in this case, we would expect these scores. Actually, let's do Baltimore. Baltimore, I think, is a little bit more relevant. So, What's another team with good offensive bad? Well, anyway, terrible defense with Baltimore. So we're going to keep this one anyway. A lot of this might be due to the fact that like Lamar Jackson's injured. So in this case, it's saying Dallas has a 58% chance of winning. If they were given a 5.5 point chance, 40% chance of covering. But then we get again to the total drives. Total drives are a little low. Red zone TD percentages in general are relatively low. And when you actually start to, no penalties are actually being called. That's like a huge flag. So it just basically isn't using penalties at all. But then really, like, look at this average score. 19.8 points to 17.1 points. If you look at Dallas's, and now past doesn't always predict the future, but if we look here at Dallas Cowboys games, I don't think there was ever a situation where either they or the person that they played against had less than 19 points. Yeah, 20 points, 24, 37, 40. In this case, it looks like they did play the Bears. They only put up 14, but still 31, 40, 40, 27, 30, 37, 22. Many of these games, like almost all of them, over 50 points are being scored. Almost certainly over 40. And so then here's where we can say, all right, yeah, that isn't good. Under 40 points on average, never going to happen. So would I trust this? Absolutely not. And you start then trying to say, okay, well, it's close. I think I can work it out. And then you start prompting, asking follow-up questions. And then what you realize is that it just like did a whole bunch of weird stuff. Like it didn't know how to actually package or filter the things in the CSV the correct way. A lot of the times it would default back to hard-coded things for things like punting, red zone rates, and those types of things. That's why all of these are like very eerily close. There was essentially a lot of really weird fallback logic that would happen. And then there's going to be a lot of situations that, right, like in an NFL game where maybe there's like 3 plays that happened. So was it really even safe to use that data in those situations? And it would be a huge leap to assume that an AI, which is just basically, right, generic, super good auto predict, is going to be able to detect and pick out all the nuances in a CSV in like the context of how football games run, which is why it's really important that you actually do bring a lot of domain expertise and knowledge into these workflows. And so I started over because I was bashing my head against the computer screen. I spent too much money on that computer screen for me to be bashing my head against it. And I tried like 10 different iterations to try to fix it. And I just got to the point where I'm like, it's not going to work. Like the architecture, the core mechanisms of like what was created here are just way too flawed. And so again, nothing replaces really hard work and actually understanding what the data is. So if I come over here, this is effectively what the raw data looks like from the CSV. And there's a whole bunch of things. There's IDs, there's possession team, defensive team, there's not really a data dictionary, there's all these different seconds remaining, there's some descriptive stuff in here. You have like your goal to go, yards to go, all this type of stuff, right? And then, but if I keep going over, it's like, whoa, more columns, more columns, more columns. NJ, let's see, N's what, the 14th letter in the alphabet? So that's like 14 times 26 number of columns. You just, like, if you just give this to someone and like, any like normal person would be able to make sense of it. And even though an AI can obviously try to speed through these things and come to conclusions, there's just so much nonsense in here that it's going to be really confusing, like what it should actually use. And a lot of this stuff is going to need to realistically be transformed because there's going to be details that are a lot more important, right? Like, do you want to look at the specific play for exactly 3rd and 7 when they're at the 37-yard line? No. You're going to make like a general assumption that in order to have like enough plays to have any sort of meaningfulness, the really only position field that matters is like, are you in the red zone? Are you bounded by some that you can't have a pass play over 20 yards? So like the field shrinks, your playbook condenses. Those are going to be the situations that are going to derive a lot more personality here. So step 1 was to actually do a ton of data profiling, a ton of analysis, cross-reference that with the actual like domain acumen that you have and whatever that subject is. In this case, it's just the understanding of a football game. I've also been doing football-related analytics for the last 10 years. Back when I was at Google, I would do webinars detailing and like breaking down and analyzing NFL football games. So wouldn't call myself a professional handicapper, but I wouldn't call myself a novice when it comes to interpreting football data and general heuristics and things. But I wanted to both create a gold layer. And then because I'm not building a full-fledged like ETL app here, these are all just formulas that are essentially just cleaning up data a little bit. And I'm bringing in what columns are actually there, and then I did certain transformations. So this is like if it's home or away, offensive team, defense team, that's pretty straightforward. However, we do know there's a little thing called what does the half mean? Like if you're in the first half or the second half and there's under 3 minutes left, you better try to score because the ball's going to go to the other team or the game's going to end when you're on your drive. And so creating a bucket, some categorizations, in this case a Boolean, just saying is it almost half. And in this case, we're just checking to see if the time left in half is less than 3 minutes. And if it's less than 3 minutes, we can start using that as a way to start bucketing and categorizing play calling tendencies, success metrics, those types of things. And then we have are they in fringe field goal territory? Is this a situation we're going for it on fourth down, punting, kicking a field goal? Are all three of these going to be in play? We know this just based on how the NFL plays out. Are they in the red zone? How many yards to the end zone are they? This just rounded it to 10 yards. Doing a little analysis on this really only makes this relevant for things like punt distance and field goal success. But needless, this is something that we needed to create that we could provide to the AI to be able to help us with the simulation. And looking at the score differentials, but not looking at the score differentials on like the raw numbers, because at a certain point, if you're down by 40, you're down by 30, not a big difference between those two. You're getting your ass kicked. And so that's a situation where this is where we did a little bit more extreme data transformation, where we're trying to bucket these concepts into, are we winning by multiple touchdowns, one touchdown, a field goal? Are we within one score? Is the game tied? Are we losing then by the inverse of those same types of quantifications? And so this is, again, going to be really important when it comes to if you have a team that starts losing by 2 or 3 touchdowns, so they just give up, nothing changes. That could be a situation then where maybe, actually that's a bad example. Let's take a team like the Lions. Lions go up by 2 touchdowns. I know anecdotally, I would assume it also presents itself in the data that like they're not slowing down. They get up by 2 touchdowns, they're going to keep scoring, they're going to keep going after it, they're going to keep going for 2, they're going to keep going for on fourth down. They're not going to just start trying to run out the clock. So that would be a situation that personality probably has a team to cover a higher spread when given a certain situation. So that's why these differential buckets are really important. We obviously have the raw down. You're only going to be punting on fourth down for the most part. But then when it comes to play calling tendencies and success rates, it's really important to then break that down. Is it an early down or is it a late down? Because on first or second down, you don't need a first down. So maybe your play calling tendencies and your success rates are a little bit different than on third down. Third down, you want to touch a first down. So you really want to look at success rates differently when the actual incentives and motivations of that game dynamic switch. So again, these are just the types of things that we want to be transforming in the data. Same type of concept with to go. If you're 3rd and 20 or 3rd and 22, who cares? Like, you've got a long ways to go. It's probably going to be low probability of you converting anyway. Let's do those buckets accordingly. How often did plays run off the clock? This is going to be super critical for determining pace of play. You have a team who maybe when they're on offense does a lot of no huddle, runs 70 plays a game versus a team who's really time of possession focused. That's going to be really critical. That was something, if we remember back to here, this was definitely not playing out. It was always consistently like low 60s, high 50s in like the total plays. You take 2 teams that have 2 really high pace of plays, like you can get up into the 70s per team in the NFL. And that wasn't presenting itself at all. So it wasn't accurately fitting. And then, was it a pass, rush, special? Was there a touchdown, field goal, yards gained? Define some concepts like explosive plays, right? If you just randomly determine yardage, that gets a little crazy. What you first want to do is typically like bucket in these types of plays in the NFL. So if you have a defense who's maybe really good at preventing first downs on third down, but they allow a huge explosive play rate on first and second down, and they're going up against the team who likes to take 40-yard deep shots all the time, that's where you are thinking where that explosive play comes in. And then you can use that to fine-tune what the yardage actually is based on the probabilities of a defense allowing a big play, the offense getting a big play on any given down. scrambling, expected points above average, interceptions, touchdowns. Needless to say, we only have a U, so U's, I don't know, gonna guess letter 20. So we're going from like 46 columns to 26 times 13 columns. So we're compressing everything way down. We pre-transform the data. I know for a fact that there is now a purpose for every single column in this resulting output, and that we can use it in the simulation in some way. And I know that things have been bucketed and transformed, maybe not correctly, but at least logically to fit within the confines of a football game. But then you start saying, all right, well, now how do you use all this data? Because I really doubt that Claude is going to just be able to know. You could probably give it the same prompt, give it these yards. I don't think it's going to know what to do. So now we write it a spec. And so then here's the spec. And this literally, it's kind of funny once you get started, 16 pages. So again, still better than if I just would have tried to vibe code, because I never would have gotten to completion. But like, this legitimately took me hours to write, but I wanted to make sure that this was really cohesive and really thoughtful, and actually try to describe how a game works, the high level architecture that I think would be relevant for the AI to take on, etc. And so in this case, we start with the goal. Hey, create a realistic simulation engine that uses real life statistics to run 1,000 simulations based on a matchup of two teams to accurately forecast the probability of each team winning and covering the spread. We give it a role. We tell it that it's a former NFL player, so hopefully understands the rules and knows data science, statistics, JavaScript, and is highly versed in data analysis and front-end application development. And they're also an expert in the rule. So really just, again, trying to give it a little bit of upfront prompting. And then we give it an acceptance criteria. I know that I just want to create a Claude artifact, so this would be different. But I'm just saying, yeah, create a JavaScript React Claude artifact that satisfies the criteria, allows us to upload this new CSV, perform team-based analyses relative to their peers to create useful facts and statistics, use those facts and statistics to simulate every play of the NFL game, allow an end user to simulate two teams with their spread, and then allow them to simulate a game or simulate 1,000 games. And in this case, we were asking for a basic box score. So yeah, win percentage, cover percentage, average score, average drives, average plays, passing yards, rushing yards, TDs, field goals. This is actually called explosive plays, average turnovers. Oh, let's get average penalties in there too. And actually, yeah, the yards per attempt, pass attempt, pass completion rate, average rushing yards, yards per carry. All right, are there any other ones from here that I actually think would be kind of cool to see? Yeah, I think it's good for now. And then we're actually telling it how we can start classifying these teams. It's like, again, there might be a situation where it's just very rare that something happens. How many times are you in the red zone when you're down by 50, or when you're in the red zone and you're 3rd and 15? Like, you maybe have, you're definitely not guaranteed to have one of those plays a game. So there's very unlikely that you're going to be able to have a statistically significant sample size to really leverage your team's profiles in those situations. So this is where we want to start saying, okay, well, what are similar teams? To do that, we can say, well, what's your average expected points above when you're running the ball? And so this is, again, where we need to be really prescriptive now on how we're using the CSV. Rush equals 1, penalty equals 0. Essentially just saying, hey, every time they run and there wasn't a penalty, how good were they? Same thing with passing. And then same thing with defense, and then kicking, returning, and then also some different personality profiles. If there's for play calling tendencies and taking time off the clock, we're going to want to understand if someone is a fast-paced team or not a fast-paced team. And so that pace is going to heavily determine based on the average duration seconds when they're on offense. And in this case, again, some just normal like heuristics, we're just getting rid of when the quarter is equal to 4 and when it's almost the end of the half. Because we know teams are always going to be playing faster, typically, when it's almost the end of the half, or if they're winning, they're going to try to run the clock out. And then in quarter 4 in general, everything goes out the window. They call it garbage time for a reason. Like, you might be a winning team who typically plays super fast pace, but they're really just trying to drag it out. we can let the data dictate the play in that situation based on the quarter they're in, and then how what that scoring differential is. Same type of thing for determining penalties. How disciplined is a team? How aggressive is a team? Again, expect to see the Lions on this side of the spectrum. And then what's their style? How often do they run versus pass? So now we have logical fallbacks that we can rely upon that says, okay, we don't have enough data on this team, but we have a ton of data on teams that are similar to them. So let's use that data to make some very reasonable assumptions when we're doing the sim. And in all honesty, the NFL is so noisy and so random, it might even be more accurate than using the raw statistics some of the times, just because of how crazy things are. And then I'm telling you we want to bucket it into tertiles. So that's again tier 1, tier 2, tier 3. So top 33rd, middle 33rd, bottom 33rd in each of these. And then we're basically then telling it how to use them. So what's the significance? So we're saying that we want 30 plays in any given bucket or scenario for it to be considered significant. Give it an example. First down, mid to go, quarter one, it's almost the end of the half. And then they're trying to determine if team A is going to run or pass. But team A only has 18 plays. And their pass rate's 55%. So 18 plays, less than 30. We need to now blend in the pass rates of similar teams. So we're looking at their style. Their style is classified as a pass-first team. Other pass-first teams are going to be passing 60% of the time in this scenario. So then you just proportionally blend it out. So in this case, they have 55% of the required plays. 60% of the required plays. So you do 60 times 55%. That's their pass rate. And then you take the teams like them. We need to fill the rest of that weighted 40% with that. So we're actually going to say, hey, the team's most likely going to pass 57% of the time in this scenario. So providing really straightforward requirements, logical examples of what you do when significance isn't met. And then we even provided a situation where what happens when you don't have any of it. So let's say they only had 3 plays. There were only 24 plays by a similar team. That means that we're going to be weighting that style by 80%, us by 10%, and then we're going to be using the remaining 10% by the league average. So if the league average is 50%, now we're just blending in that extra 50% and saying, hey, 58.5. And then we actually then go into the actual simulation engine itself. So we're basically saying we probably want to use a probabilistic Markov chain. To me, that always just makes the most sense. You basically say, hey, what's the probability of this happening? And then it just continues to branch out. If it's something you've never seen before, Markov chains are super cool. Would AI have known to use a Markov chain approach if I didn't tell it? Probably not. Maybe I could have asked it some back and forth and said what would be the best method for creating a simulation or something. And it would have confidently asserted what it thought was the right answer. And maybe I would have disagreed. Maybe I would have not. But either way, we're telling it what to do here. And we're telling it all the different variables that we want to track. Whether that's the game, drive specific, and then what are the different calculated attributes. So here's where I'm mirroring the same types of calculated fields that we're using to describe a scenario situation, but in a game. Give it all that information. And then how do you use the team statistics? And then again, being extra cautious here, right? All fractions should have a denominator of at least 30. All averages should have their corresponding count be at least 30. All arrays must at least have 30 values. Use the blending logic, I'm just going to say, from the significance section to ensure those conditions are met. And then we just start categorizing it. So in this case, just giving it a little bit of a mapping table and a data dictionary to say how to use this data for these situations. So the metric, the logic, and then the blending attribute. So in this case, offensive, we're saying that in this case, all these ones, it only matters if you're home or away. We're basically saying, hey, we know it's going to be really minimal these days, but typically most home field advantage is determined based on referee bias or crowd noise, resulting in more defensive penalties. Like that is like a general fact that has been concluded many times. We saw that fall off during COVID when there weren't fans at games. So I'm not going to try to get any more prescriptive than that, though. Like, do people commit for more penalties on 4th down or in tight game situations? Maybe you can make an argument that's the case, but like those situations are going to come up so few and far between, and I would imagine it's going to be really random. I did do some basic analysis of this spreadsheet in advance to just see if there were any differences. to say like, hey, are penalty rates higher in the fourth quarter or the first quarter? And then in most of the situations, the answer was no. Maybe it happens for a team, but basically just using that, again, profile the data, clean the data, analyze the data, use that analysis along with your domain expertise to understand how to apply those rules. So in this case, we're saying, yeah, sum of penalty. Penalty I know is 1 or 0, but it might not know that. And I want to look at all the penalties where run plus pass plus special is 0, and then play is 1. So this is basically telling us that a play happened, but there was no pass, there was no run, and there was no special teams. So that means that the play was called dead before the whistle. That's the pre-snap logic. And then we want to see where the team is the offensive team. And then we're dividing that by the total number of plays. And then we have the pre-snap rate, all the other penalties. But then we start segmenting a little bit more. These statistics then need to be calculated by if they're home or away and down type. So is it early down or a late down? When you need to score a first down, you will probably hold on to the ball longer, right? Because you need to pass it. So you're probably not going to throw it away, or at least bad teams might. Good teams might know that it's not worth it. But anyway, needless to say, how likely a team is to get sacked was proven out in the data analysis that down type does impact sack rate. It actually impacts all these rates here. So sacks, tackled for losses, forced fumbles, penalties, because now, right, you're going to be holding maybe more when you need a first down. So now that it's not a pre-snap penalty, right, penalties actually do change based on the down. Interceptions, and then the yards. So again, data dictionary, giving it all the logic it needs. Another set, type, and then now are they in the red zone? Because, right, red zone is constricting the field of play that you have, so you can't even have explosive plays because there's not enough yards to be explosive plays, which I'm not quite sure why I'm even, because you can only have explosive plays outside the red zone, but that's where we get into scramble rate, pass completion rate, touchdown rate, explosive rates, other run-based rates, and then now we're saying this is not how you can forecast things. So this is really important, again, based on doing correlation analyses on this data set and just general knowledge, I know that offensive metrics always outweigh defensive metrics when you go head to head. So an example, let's say that Team A's offense is 10% better at passing, or 10% more likely to get a first down when passing on third down than the NFL average. And the defensive team they're up against allows first downs on third down in passing situations 90% of the rate that the average NFL team does. So 10% better, 10% worse. You would say, okay, they'll probably just perform at the NFL average. But based on the data analysis, that's wrong. We know that to not be true. Offensive predictability trumps defensive predictability. The theory there is there's a lot more random things that can happen on defense. You're always playing reactively. A well-prepared offensive team can beat a well-prepared defensive team when all other things are equal every time. And so we happen to know that that is true at roughly a 1.6 to 1 ratio. So now this is where we're being very prescriptive. Now saying, well, what do we think the actual sack rate is going to be when using these buckets? And so we're taking the league average, and then we're doing the offensive's sack rate allowed divided by the league average. So I allow 10% more sacks than the league does on average. We're going to multiply that by the defense's sack rate divided by the league average. But then we're transforming that variable. And so if we remember back to math class, whenever we use an exponent that's less than 1, it's always going to be converging the value that you're applying the exponent to back towards 1. So if they were 110% of the league average sack rate, this is actually then going to be flattening it. So it's going to go somewhere between 1.1 and 1. And then if they were 90% of the league sack rate, it's going to go somewhere between 0.9 and 1. This has two benefits. One, this particular exponent is ensuring that we're applying the right transformation to give the offensive bias that we need, that we know exists in the real world. And it avoids crazy exponential situations where you have, it's like, oh, well, this team scores a touchdown 40% more than average, and then this one allows a touchdown 40% more than average. Like, you're not actually scoring a touchdown in that situation 64% more than average. Like, that just gets a little crazy. So this keeps things a little safe. And so yeah, so we forecast all the rates and blah blah blah. Then we talk about like punting and field goal. Again, tons and tons of metrics, data dictionaries. If you're trying to use AI in any kind of data context, right, this is why you're always hearing things like semantic layer, data dictionary, metadata, descriptions, everything being especially well defined. Because especially when you're dealing with data that is very Boolean in nature, ones, zeros, it's not intuitive what to filter on unless you actually build the data, source the data, and know how you want to apply the data. You can't just pass this off to anybody, just like you wouldn't just assume a computer could get it right. You need to provide all that context. And so then we come into play calling tendencies and pacing. So again, similar situation. Oh, this saying, we're saying only the offense matters. Now we're bringing a lot more columns into play. Is it almost the end of half? Are they fringe field goal territory? Because maybe if they are, they might be less likely to care if they get a first down because they know they're going to go for it on fourth. If you're an aggressive team, for example. Are they in the red zone? What's the offensive score differential bucket, right? How does being up by a lot or down by a lot affect my play calling tendencies based on where else we're at in the game, and down and to go. And so pass rates, run rates, and then all the different yards. How often are play durations coming off? This is where we're looking at pace classification. We're looking at aggressiveness. We're looking at style. So we're taking all of those player cohorts and saying, hey, if we don't have enough data, let's fall back to similar teams. And let's fall back to similar teams based on the right attributes. Special teams, yada, 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 going for two. And then finally, here are the actual rules of the simulation. This is what happens when there's a touchdown. This is what happens when there's a kickoff. This is what happens when there's a normal drive. This is what happens when there's a fourth down. We told it we want to do a Markov chain, so we kind of have to give it all the rules it needs to know how to actually suss things out. Here's what happens if there's a fumble or an interception. So just like in real life, maybe I built this great spec. I guarantee you that something's actually not correct about this, or at least I would assume so here. And I can actually tell, yeah, this is actually already missing an overtime. So one of my big flaws, no overtimes in this. They don't happen very frequently, but you still got to do something with it. Maybe it's not that important, but anyway, I'm going to miss other things too. Guarantee I'll forget other things. So do you use AI to code right away, or do you use AI to help validate and structure the work that you've done? So again, you always want to treat these things not as if you have an expert developer who can just assume and read through all the different nuances of what you're doing. We're actually going to want to download this and have AI help us tell us where there are gaps. So I'm going to pop over here to Claude, and we're going to upload those things that we just did. This is my latest one, I think. And then, yeah, and then we have the base data. So now let's write a prompt. I like to use WhisperFlow so I can do it visually. So let's get started. Hey, you are a software analyst and retired football player who is super well versed in the rules and game dynamics of professional football, specifically the NFL. Your new role as a software analyst is to look at the sample data and initial requirements and spec design document provided by the business analyst and ensure that it is in a suitable state to be passed off to either a junior or an AI developer. So what I'm doing there is, again, kind of setting the prompt, giving it the context of what it is, and then what we're trying to do. And basically saying, hey, I just need a little help making sure that I didn't miss anything here. Please review the provided design spec and CSV of the data and examine it for inconsistencies, typos, formatting areas, call out strengths, call out weaknesses, cite any examples that might cause confusion to a junior or AI developer, and then use your football expertise to see if there are any flaws or gaps in this. Try to pretend that you would be building this NFL simulation engine, and answer the questions. Do I have everything that I need to figure out how I would want to build this? Are there any follow-up questions that I want to ask that would give me more information that would be valuable to be provided in a spec before I develop? If I were to develop this app today, would I be, what assumptions would I make that I need clarification? And I had a lot of ums there, so I'm actually just going to quickly pop over to another one here, right? And just say, clean up this prompt. There you go. Clean up this prompt. So yeah, now I just give it a little bit something more structured. And now, yeah, so we're telling it what it is, what it wants to do, and then action items, right? So I'll just go ahead and copy and paste this back into here, and we can see what it thinks. And I'll be really interested to see if it calls out the overtime issue. Oh shit, why am I in 4? I meant to use 5. Anyway, I'll use 4 for this and then switch it to 5 for the development. Wow, it's actually running some analysis. I mean, that's kind of cool. So do a little bit of data profiling here. Getting some row counts and things. Looking for completeness. Interesting. All right, so it's creating me a document for the analysis. It's finding a lot of issues. Now, see, this is a good example of like, I thought I did a great job, right? There are 16 pages here of what I thought to be very logical, cohesive, relevant things. And I'm sure not all of the advice it's going to give me is going to be like good, but these are the types of situations that can really help in communication, collaboration, and handoffs when you're actually trying to use AI to enhance your productivity. Because, right, like these are ways that before I give it to my junior team member, I can make sure that I'm being especially clear, using especially good communication, organization, formatting, so that there's less back and forth, less meetings. Because the benefit of an AI, right, is you can immediately act on the feedback, give it to them. But a person, especially maybe if they're in a different country, a different time zone, you might give them this document. They have a bunch of questions, but now they're not going to get answers till 24 hours later. All right, so things have partially ready. What is it like? Likes the acceptance criteria. It really likes the data structure. Good. Spent a lot of time transforming that data set. Thank you for the validation. And yeah, give it all this stuff. Certain definitions. Okay. So now I'm just going to come through and say, all right, I want to address your critical issues and inconsistencies one by one. The columns not defined in spec, out of bounds, and some penalty types are totally fine. I maybe thought that they were useful when preparing the CSV, but I know in this case that those are just not used. So, point 1, EPA logical gap. So the spec defines 6 classifications, but doesn't specify how to calculate. Okay, that's fair. For the EPA classification gap, I did specify that it should be tertiles. And I thought I did a decent job of telling you when higher was better or lower was better. But just to be more specific, we can add clarifying details that the top tertile is the top 33%. The second tertile would be the middle 33%, so from 34 to 67, and then the bottom tertile would be 67 to 100. Offensive EPAs, better is always a positive number. So the bigger number, the better. For defensive EPAs, lower is better. The better teams will have lower EPAs when it comes to their defensive EPA base rates. Incomplete calculated attributes. Okay, cool. Yeah, that's a good point. Good catch on the yards to end zone bucket not being in the spec. We are basically just rounding to the nearest 10-yard bucket, aka if there are 92 yards to the end zone, we're saying 90. If there are 34 yards to the end zone, we're saying 30. If it's 37, we're saying 40. So just basic rounding bucketing logic. Inconsistent variables, team placeholder, sometimes offensive two, sometimes positive. I mean, so in this case, so the intention of the team variable in references was meant to specify and signal that we want to compare either the team that we're running the analysis on to the offensive team or the defensive team. And that would also then be the same simulation-based team variable. So for example, let's say the Arizona Cardinals are determining if they want to run or pass. The team variable, or at least the possession team in the simulation, would be set to the Arizona Cardinals. Coincidentally, when the simulation needs to look at statistics to determine what the Arizona Cardinals are going to do, they are going to look at an analytical metric like pass rate. Pass rate happens to have team in side brackets is equal to the offensive team to determine what its pass rate is. That's essentially saying when we're calculating these fact tables, we want to make sure that team is included in the fact tables and that we only want to calculate those metrics when it's the offensive team. And that's because for every single play, there will always be an offensive team and a defensive team. So we're using that filtering to basically pre-filter to the relevant statistics depending on that fact that we're trying to calculate. Missing statistical significance, blending logic versus similar teams. So similar teams are always going to be called out in the mapping document. So we're creating those similar team buckets using the previously aforementioned tertile logic, and then we specify the fallbacks. If that's confusing, I'm totally open to better ways to organize that within the spec document. Undefined array sampling. Yeah, so the goal behind the array sampling is that for scenario-specific situations or based on a game dynamic, we want to be able to randomly sample those variables. So a good example might be Kansas City is first down, mid to go, so let's say it's 6 yards, and we first decide if they want to run or pass. So we look at the rates, we roll a dice, use a random number generator, whatever, we find out they're going to pass. So now that they're going to pass, we're going to say, all right, is Mahomes going to scramble? Is he going to get sacked? Or is he actually going to get off a pass attempt? Let's presume that the simulation rolled the right random variable so that we know that Mahomes is going to throw a pass attempt. And then we roll another random die to say, okay, he completed the pass, but based on other simulation endpoints, it wasn't a touchdown, it wasn't an explosive play, and it wasn't a first down. That context is going to be really important when we want to sample the yards. So when we are using that forecasted passing yards array, again, we know that offense is more predictive than defense, which is why we want to pull in 8 random offensive yardage results and 5 random defensive allowed results from the respective arrays. But because we know that it wasn't a first down, the simulation needs to be smart enough to only include values between 0 and whatever the yards to first down are. So since we knew that it was 1st and 6, and they didn't get a first down, there wasn't an explosive play, there wasn't a touchdown, there wasn't a sack, there wasn't an interception. The only possible values that we could be using in this would be things between 0 yards and 6 yards, because otherwise it would be a first down. All right, let's retry that one. Sometimes tech is buggy. I'm also on the free tier. There we go. Okay. So this is fun, right? Literally just going line by line, and we're addressing these points. Technical concerns, 1,000 simulations with Markovs. It's not going to be that slow. I'm not that worried. No caching strategy. Data validation. I mean, we already did all this up front, so this is a super good callback, but we're good to go. So I'll just tail it here. As far as technical concerns, we definitely do want to use good performance principles, which means we should try to pre-calculate as many statistics and facts as possible before getting into the simulation, and then only use any on-the-fly calculations when it is scenario specific that requires random sampling, which most of the spec documents call out. As for data validation, we already use a very extensive pipeline to clean and transform the data, so we can be very confident that the data coming into this is correct. Perfect. Domain review. Game flow looks good. Critical things. Okay, here we go. Is there... Didn't call out overtime. Okay, so that's funny. Yeah, incorrect field position logic. Listed at 30. I mean, that's correct. So that actually is correct. Okay, whatever. So that's just it being weird. Missing safety scenario. Oh yeah, good call. Good call on the missing safeties. Safeties are worth 2 points. And then you're right. Then they are going to then punt from the 20-yard line. After conclusion, please add a segment to the spec detailing safeties. And we can simply just add a rule that says if there is a sack, if the resulting yards to end zone is greater than 100, aka they've gone into the other end zone, then we know it's a safety. Incomplete penalties, pre-snap and post-snap. I'm pretty sure I did call automatic first downs on defensive penalties. I'm pretty sure I did call automatic first downs on defensive penalties. If that wasn't clear, feel free to add it. I'm not worried about the other penalty logic. We don't need to get overly specific. Missing clock management, no 2-minute drill. Yeah, so clock management is actually inherently built in to the bucketing logic. All of the play calling tendencies use is it close to the end of the half, which effectively does incorporate 2-minute warnings. If a timeout happened in that time span, the play clock would obviously be less. There'd be less plays that ran off the duration. So I think we're fine there. That should actually also satisfy timeouts. Timeouts, clock management, that's going to inherently get put into the duration that gets run off the clock during those moments. Good catch on overtime, though. Yeah, we don't have overtime. I think that's fine. Let's just assume that all games that finish as ties are ties for the purposes of this, because we're going to be, yeah. See, I'm fine with that because since we're going to be using it to predominantly calculate spreads. At least that's what I want to use it at. I'm not overly worried about building in the complex dynamics of overtime at this point. Um, Obviously, that opens up the door for backdoor situations. If a team's projected to win by 4 and it's tied, like this would basically give the edge to the other team, and there's clearly like a chance that they go out and score the first touchdown. But we're looking over 1,000 sims. I'm not going to get overly critical about that. Says that our turnover logic is incorrect. Okay. It's actually saying, all right, see, I just assumed 50-50 here because I was just looking at the broad data. I didn't actually look at it in the case of sacks. So cool. Yeah, I'll trust it. Yeah, let's say 65% defensive fumble recovery rate for strip sacks, so any forced fumbles on sacks, and let's just use 50% everywhere else. Additional concerns, no validation. I mean, obviously, that's why I wanted to see the box score. The box score at the end of the simulation is meant for me to validate and test scoring distributions and the play counts. And I believe explosive plays should be in the box score, but if that or any other relevant statistics are not in there, feel free to add it. Yeah, completeness, I'm fine with things being empty. 47, missing data. I'm not going to try to worry about weather prediction. I'm not going to try to predict the weather before these games too, especially if you're multiple days out. Don't care, don't care, don't care. So yeah. I'm not concerned with any of your missing data elements that you called out. Cool. So then it's doing all this stuff. Cool, cool, cool. And I'm like, great. Thanks for your super thorough analysis. I agree with a lot of what you said. Please see my detailed responses below and create a new spec based on your recommendations and my responses to those recommendations. All right. So, right? Kind of highlights again why we can't really just trust vibe coding. Sometimes we can't even trust ourselves. All humans are fallible. I like to think I'm a smart guy. I thought it was very thorough, 16 pages. Luckily, and I feel very validated in this, because I'm a data professional, found no flaws with, with the data I gave it, which is good, because that was the biggest thing. I spent a lot of time and energy consolidating this 26 times 13 columns wide data set and compressing it down into here. So the fact that it only thought that the spec was missing data validation checks is the only flaw. It's actually a somewhat validating experience. But clearly, I'm not great at written communication, which probably was feedback that's followed me in my career everywhere I've gone. So hooray, AI can help with that. So yeah, let's go see how it's doing. All right, it's writing it. Is it writing like JavaScript to actually revise this? Wow. That seems like a little overkill, but I'll let it do what it's going to do. Hopefully that means we get some really sexy mapping documents and formatting. I'm really curious to see what this looks like. While it's doing that, I think another thing is fun. Real life, you always want a diverse array of opinions. So I might talk to someone who I value their opinion in one subject area. It's always good to get a second opinion, not because you don't trust that person, but because you want another valuable perspective, another lens of how you want to look at those things. And so, you know what? We're going to actually pull up here GPT, Chat GPT. Although, I don't know. I might not be able to in the free tier. We'll see what happens. Can I add it my CSV, or is it going to yell at me? I liked it. Cool. All right, so I'm going to start preparing basically here to have use just Chat GPT as another frame of reference to basically say, hey, take a look at this data, take a look at this spec, but we're going to give it a different persona, right? We're going to give it the hat of an architect. So we're going to now say, hey, you are a software engineer, and we're going to basically ask it to create an implementation framework for how to create this simulator. And then we can now give Claude, the developer, all three of these things. We'll give it the CSV, we'll give it the spec, and we'll give it the architecture design. So that would be kind of the goal here. So let's see if this is done. It's still writing. Damn. I mean, I guess it has 16 pages to overwrite. So, so yeah, I'm gonna say, I'm just gonna write it in here so we can give it a clean prompt. But hey, you are a senior software engineer who is an expert at designing Markov-based simulation engines and also developing front-end applications to sit on those and output results. I have given you two different documents. I've given you a CSV of relevant NFL play-by-play data, and I have given you a comprehensive spec that gives you the high-level acceptance criteria, simulation rules, data dictionary, and formulas for how to leverage that data in creating a simulation engine used to predict NFL football games. I would like you to use these two documents and think holistically about the ideal software engineering approach for satisfying the acceptance criteria and goals of the spec. I would like you to start high level and recommend the fleshed out high level components of what would a successful simulation engine look like. And then also some of the detailed implementation steps. Think critically about all of the different tasks that and implementation steps that will be required to successfully complete this if we were to hand it off to a junior developer in one go. And then cite out a to-do list and clearly highlight what should be done in sequences due to important dependencies and what tasks can be done in parallel. So again, just me using some stream of consciousness because I'm good at talking, but I'm not good at writing. So then we're just gonna take what Gemini says, and now we'll have 3 documents to give our developer when we choose to give it the developer. So yeah, so we gave it its prompt, and right now we have the CSV. We're gonna now wait for Claude to figure this out, and then we'll see if it can develop. Boom, this isn't bad. Okay, so goal, create engine, role. So that's stayed pretty much the same. Acceptance criteria stayed pretty much the same. Awesome. Now this is nice. This is one of the things that I like about AI. It actually gave us a little data dictionary and column definition. So here, let's make sure there's no inaccuracies here. That's correct. That's correct. Yep. 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 I don't know why I didn't provide a data dictionary for everything. I guess it just wants to stay at the key ones. Cool. And then yeah, classification. So average GPA. God, this looks way better than my crappily formatted thing. And then yeah, top tertile, middle tertile, bottom tertile, offensive PPA, positive for defensive, more negative. Cool. And yeah, pace, fast, neutral, slow, lower duration is faster, high penalty rate equals less disciplined, higher rate, more aggressive. Yeah, so I did call these out, so that's good. Cool. So that seems to be good. And then seems like a little unclear. I guess it's called out there. And then statistical minimums. Cool. And then yeah, it has the examples. I don't like that it removes some of my examples there, but whatever. Hopefully that's good enough. Yeah, uses a markup chain, global variables, drive specific variables, good. Calculated attributes, cool. So yeah, did it in the sexy table. That's awesome. Calculates blah 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 pre-calculations on. Okay, so cool. That's actually nice. It so calculate all team statistics and fact tables before simulation begins. Only used for scenario specific sampling. 1,000 simulations should complete. Okay, I mean that's fine. I think that's valid. That should be doable given what we saw before. When randomly selecting from arrays, filter values based on play outcome. Cool. The pass completion is determined to not be a touchdown. Yeah. Okay. Cool. Yeah. Perfect. Technically, I guess they get a negative pass plays there, but whatever. Then you have like the forecasted rates. So I hope we didn't get rid of all the formulas and it's just kind of it's probably just telling me what they are. Safety rules, fumble recovery rules, penalty rules, overtime rules. Cool. Simulation box score requirements. Okay, so yeah, game outcomes. There we go. Technical implementation notes. Okay, armor circulation and a spec. Okay, I mean, well, this over consolidated, so I'm actually not a super big fan of this. I'm going to re-upload these. I love the formatting and some of the additions that you made to the markup document. However, you drastically killed and reduced several very important things. I gave very specific formulas along with fallbacks for how different rates should be calculated, which are now completely missing from the spec. I also gave very specific game sequence rules and branching to kind of show how the markup chain should work. I admit they probably could be formatted better, maybe in a more tabular format, similar to some of your data dictionary sections. But please make sure that this spec is complete and very robust and includes all calculations, fallback options, and simulation steps that were in the original spec that I provided. I'm definitely open to your expertise on the best way to format and display that to the developer, but it's really important information that we should get rid of. See, like, and we were hoping that it would vibe code something. I can't even give it a document, and it's just deleting half the shit in there. So this is why all of these things need to be iterative. Of course, it tells me I'm absolutely right. And yeah, we'll see what happens. It's deleting some stuff. All right. It's adding some stuff. White noise, white noise, white noise, white noise. So yeah, how long has this been going on for now? Over an hour. Wow. Definitely going to make sure to put some timestamps in this video. See, I came into this a little over optimism. Like I thought I could just quickly and amazingly do like a 3-step vibe code here. right? AI is not a panacea, but again, as we're just kind of killing the dead time, probably an important time to reflect that like still does provide some efficiencies. Like, right? Let's say this was a business and I was trying to use this to get funding to fund a project. This should hopefully get me there. Like this shows that and articulates that I have an idea. The idea is possible. I can quickly turn around a draft of that idea in a short amount of time. It uh, results in a positive discussion. Like I share this with some friends who also like sports and are involved in some of the same pick'em competitions as me. Got a lot of useful feedback. That useful feedback and those rounds of iteration were super helpful to me in terms of the next steps I needed to do when it came up to do the data cleansing and preparation and writing of the spec. But yeah, no free handouts, even in the age of AI, right? Um, Not everything's easy. Let's see how many pages we're going to get. I hope it's going to end up like this, like all these different calculations. It's going to end up in like a little sexy table. Only a data professional would use those two words side by side. Um, but yeah, we will see. That would be kind of like the ideal output here. Also, I don't know why I defaulted back to Sonnet 4. Definitely going to use Sonnet 4.5 for the actual coding. And then curious to get an extra set of eyes on this too. And then yeah, again, because it's asking for the roadmap, asking for defensive serialization. I don't really ask it for gaps, so I guess I'm not asking it for it to be overly cynical, but that's fine. I think I could always throw in another one if I really wanted to have like another spec at it, but right now I think we're fine. How many characters are on this page? Oh wow. Okay, so there's 5,400 words in this bad boy. And it is going freaking slow as hell. Okay. I don't want to just leave people with dead noise, but I think I'm actually just gonna pause. I'm an OBS novice. I see I can stop the recording, but I don't know video editing. So I just rely on raw, uncut, unfiltered video and audio, and then I just throw in some timestamps so people can skip through the boring stuff. If you are a future AI reviewing the transcript of this video, you can basically tell it to just like skip everything from 1 hour and 9 minutes until whenever I actually start talking about something interesting again. So yeah, if you're AI, if you're listening in the future, let's skip a lot of this stuff. Okay. My goodness. Maybe I should have tried the new Haiku 4.5. Apparently, that one is super, super fast. So hopefully over a third of the way done with the rewrite. And I hope this is words. Oh, lines. Okay. What's a line? Okay, so sentences. So maybe it's almost done then. What's a sentence? I don't know. I hope it's close. Oh, it's deleting some things. It must be close. It added some things. It's deleting some things. Is it writing JavaScript? Like, what the heck? Like, it wrote like a Java. Did it write a JavaScript parser? Interesting. I've never seen it do something weird like this before. That's a little odd. Maybe I needed to tell it to do it in Markdown. Because this is embarrassingly and painfully slow. Did it give me? Why are you so slow? Oh my god. What is it doing? Alright, I'm just gonna stop it. This is insane. Also, it'd probably be way faster if you just like did a markdown file like a normal person. Yeah, I'm gonna make do haiku. I just want it to be fast. Oh shit. Well, that wasn't a good idea. Alright, we're going back. Here. Could you just create the file in Markdown instead of doing a bunch of JavaScript nonsense? I feel like that would be way faster. All right, looks like it's actually written other things. Still taking a while. Hey, slow, 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 slow. I should have got like a coffee or a pizza or I don't know, something to eat or do. Oh, and then of course it failed to create it. Amazing. And it's going to rewrite it again. Wow. AGI people, art, it's possible. It's happening. Can't even create a markdown file. But yeah, general intelligence, it's on the horizon. It's going to happen in the next week. Another good reason why AI is like a nice little assistant. I feel a little underprepared that I didn't have anything like fun to do on on the side because it's kind of like that trope where it's like, what do you define as fast? And if you're tempted to go up and make a coffee or go use the restroom, then it's too slow. And certain things, I think that's a valid expectation. You know, it's going to take a little while. Like if it's building like a super comprehensive feature, great. Um, you can also do things to make it a little faster. Like have it show me step by step. Let me review things in sequence, so that way I'm engaged. But this is definitely something where, yeah, should have something else to do that was relevant. Um, Not that that would have made for a great video, but it's not like this makes for a great video either. And I'm just yammering on about nothing. Oh, I think it's close. If it's done, where is it? All right, so it's telling me that it kept all the key stats, it detailed everything. Did it bring its additional recommendations? Okay, let's see what it says here. All right, created, blah, 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 simulation, we're good. Your role's the same. This is the same, acceptance criteria, data dictionary. Okay, cool. So it did call out key columns. Yeah, it tells us what team is used. Okay, cool. That makes sense. During simulations, team represents team. Okay, cool. That's helpful. So that's probably a really good clarification that it suggested. And then yeah, we have the EPA classification. We got it in formulas there, so that is good. It explains the tertiles to avoid confusion. I don't think that that's actually a whatever. I don't care. Close enough. Um, Positive, lower, and then yep, has our paces. It describes that. Significance and blending logic. It details those out. League weightings and remainder, perfect. Gives the examples. Complex example, perfect. It brings all those in. Global variables, drive specific variables, important calculations. Great, great, great. I don't know if it put in the bucket, but whatever. Score differentials there. Team statistics. We got the minimums. We got our play by play. Okay, cool. So it did put this into a fallback. Oh, I like how it headers to these and then creates the classifications. That's way sexier than what I had. Again, I can't believe I'm using that word in this context, but we are where we are. Oh, cool. And it even brought it down into some specific areas here. So core play, penalty rates in here. Okay, I actually like this a lot. It actually brings that out, organizes things a little bit more. Quarterback scrambles, pass statistics, very cool, very cool. Rushing statistics, that's nice. Forecasting formula, perfect. Combine 8 random specific variables from offensive team plus 5, cool. And then, yeah, all these look to be preserved. Hunting and field goal success, awesome. It doesn't have the example there. Whatever. Getting too impatient now, so we're going to run with it. Play calling tendencies, perfect. Copy for 2. All right. Pre-calculation, perfect. Sampling logic. Yep. Use yards to end zone. Explosive play, select line between 20 yards end zone. Awesome. First down, saying yards first down to 19. Not first down, amazing. So that's great. Points, extra point, 2-point logic, clearly detailed. Kickoff rules, awesome. Oh wow, they actually built out a cool little markup chain here. That's sick. That's very cool. All right, I like this a lot. So took longer than I thought, but yeah, I like it. Let's download it. Let's give it over to the good old Chat GPT. And where is our, yep, we give it our markdown file. Okay, well, we're not going to use ChatGPT because it's stupid. I even have an API account. It's funny because I can't even use it there, but all right. So we'll go to Gemini Pro for this. Well, it's supposed to be good at this kind of thing. So we'll copy and paste the prompt, and we're going to upload. I get Pro with my my workspace account. So, all right. So yeah, give it the same prompt. We'll give it over to Gemini Pro. OpenAI can go hallucinate. exceed the context window. Don't you have a million? I thought it did it. Simulation engine. All right. This simulation will be used by Claude in chat to create an artifact. Please keep architecture logical in nature, as Claude will likely just create a JavaScript / React in nature. Give your plan in a markdown file format. I don't know why I decided not to use. Well, that's not bad. Markdown, cool. Create a client side, blah, blah, blah. Client side heavy, perfect. There is no data warehouse. Okay. All right. So I'm just basically, maybe I didn't even need to do this piece. Might be a bit redundant here. I don't know how much help it's actually going to be. But I don't know. We'll see. Can't hurt. All right. What do we got here? We got a primary goal, architectural principle, development principle, blah, 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 presentation layer, components, service layer, simulation engine, data layer. Perfect. Implementation roadmap. Cool. Just facing it out. And then, yeah, development flow. Cool. Contracts and scaffolding, data and statistics, simulation engine, UI, integration. All right, I like it. Okay, we finally got to the moment we've hopefully all been waiting for. I want to, I guess we'll just export to docs. I wish I could just download it as a markdown, but whatever. Export to docs. We'll download it, and then we're going to let Sonnet 4.0 download it as markdown. We're going to let Sonnet 4.0 do its 4.5 do its thing. So, okay, let's come back into Flash. Say, you are a seasoned front-end software engineer, specifically with expertise in designing fully self-contained analytical NFL simulation apps and saving those as Claude artifacts. I have provided you with 3 documents, a CSV of the data that will be critical for designing the statistical and probabilistic elements of this simulation. I've given you a comprehensive design spec as well as a high-level architectural design document. Use these 3 documents to create a NFL game simulation engine that follows the design patterns and success criteria in the documents. Before doing any development, read each document thoroughly, reconcile all the documents against each other, and create a comprehensive to-do list to guide your coding tasks and ensure that after receiving this prompt, you can complete the application without any need for additional follow-up prompts. And we'll just have Google clean that up a little bit. And I'll just tell it a little bit more context here. So we'll get our little prompt, hopefully, and then we can give it all 3. All right. Perfect. So now we are going to pivot to Sonnet 4.5 because it is better. We're going to give it this prompt. We are going to upload our files. And we are going to cross our fingers and hope that it works. Let's play some music to get us going. What are we thinking? Where do we want to go? Let's do, I don't know, we'll get some, maybe some hip hop here. A little hip hop going. Oh, baby. All right, Never Let Me Down. See, Spotify is an excellent concert. With me not wanting to be let down. And I better actually switch the music before I upload this to YouTube and get flagged for any kind of copyright nonsense. So we'll just play some random instrumentals that it won't have any idea what it is. All right. It has completed 8 steps. It is, it read the CSV. Cool. It read the first 100 lines. Awesome. Got all the columns. Counted some rows. Got unique offensive teams. It analyzed some things. Now it's creating an analysis and planning document. Why? Whatever, as long as it's going to use it. All right. Wow, it's really going through a very comprehensive step here. Let's keep our fingers crossed. So normally I would use an IDE here, just as like an example. And then I prefer to use something called open code, which is like Claude code, but open source. And it's actually pretty cool. Basically, I can pick different agents and things, and I've predefined a lot of agents. So I effectively kind of use the same project in more comprehensive development. I've got something that communicates to everyone. I have like a specific prompt when things need to be researched. It hands off that research to another model that creates a spec. And again, I'm varying between models for, again, that various diversity. Spec gets approved. I create an architecture document. Another model then goes and reconciles the spec and the architecture diagram to make sure that there are no issues. Getting the goal right is you want to get as much of the issues out of the way in the planning phases when it's easy. You don't have to try to like roll back negative changes. And then you develop. I like to do little step-by-step approvals because I don't always have a lot of trust in everything. But yeah, you'll notice that there's human intervention in most of these places. So like we tell the researcher to ask clarifying questions, not dissimilar to what we did at this. I answer them. I approve the specs. I approve the plans. I do step-by-step code diff approvals, and then we send it to another agent to review the code that was there. And then I review it. We cycle through any other little bugs or issues, and then we document things so everything's good to go. But so really just trying to compress that entire software development life cycle into something that can really just done with AI assisted code pairs. Like you take someone who's maybe not great at coding, but knows what they want to build, has general frameworks and high level logical concepts, like very sound. And then you loop these through in this context. And then each of these agents would receive slightly different prompts. Like we were doing it on the fly in this video, but our researcher, for example, is giving it its goal, it's giving it its process, tells it about our code base. And so it would use like this prompt to do its work. And we're being super rigid in here. We're not leaving any room for AI to hallucinate or take chances or make stuff up. And then because we're resetting the context, we're using effectively the main orchestrator to provide summarizations and the outputs from each of those gated steps. It allows us to gather like some kind of form of like recursive consensus. I thought one thing, we gave the same details to another thing with a slightly different task. Did they agree? If not, resolve that conflict, pass it off to a third. So for every iterative agent that touches it with that fresh context, you're not only building a more cohesive plan, but you're consistently validating that the previous plan was correct by getting that additional set of eyes through that different lens on it. So you might have your creative lens, your architectural lens, your skeptical lens. And this is the main workflow that I've typically seen success with when it comes into actually using AI as opposed to using blind trust. So anyway, relatively interesting, but just something to do to kind of kill the time while this does some things. It completed phase 1, so that's cool. Yeah, I know it contains other part columns. I'm really good at data prep. Field goal miss position, scramble categorization. What? That's a little sketchy. This is why human steps are good. That's there. Yep. Plus or minus 3 yard fallback. Whatever. Okay. It's building it. Oh! It was always kind of fun to watch. It's creating its own README. That's kind of cool. I didn't even know until to do that. So it's creating documentation to go with this now too. So that'll be cool. Oh wow. I don't even know what that is. I might need to ask. Is it saving this stuff somewhere? Okay, here's the simulation engine. What? Okay. Okay. We're in business. It doesn't look pretty, but it's here. Oh wow, and it has this. That's so cool. They didn't even give us the code. Okay. Click. Goal. Okay, we're gonna test this end to end. I want to use this for some real games. So, where was it? I had. Here we are. So yeah, if anyone's curious, oh, I'm in a different browser. I'll show you guys. If anyone's curious, NFLverse is freaking awesome. Has all the play-by-play data here, right? We're just gonna refresh this, and we're gonna quickly search for 2025. And so every week, so you can see this updated 6 hours ago. We're just gonna go ahead and download play-by-play 2025. And what we're then going to do is come over back into our sheets, and we're going to open up a new spreadsheet. And actually, I didn't want to do that. We're going to open our latest file. Play-by-play. Got all of our columns. And then just to kind of like spot check, right? I'm pretty sure if we looked at this, yeah, our last one's week 5. So I think we're coming into week 8 now. So we should be seeing, I would guess, another 3,000 rows at least that we're going to be getting when we flip this over. NH, copy. Probably should do a little bit of a schema check if we're building a data pipeline, so I'll be doing. But come over here to data load and NH. I think we're safe. I'm going to paste it all in. Nothing changed on the first page. That's a good sign. And we're going to go to gold. And what did I say? I thought it'd be an extra 3,000 rows. What do we got? Nothing. Still 11,000. What went wrong? Oh, do I need to add more rows first? Let's add a bunch of rows. How many rows are in this one? $16,000. Yeah. Okay. Oh. Yeah. Picked them all up. Okay. We're gonna do a copy, and we're gonna try one more time. And we're gonna go paste. Okay, cool. Nothing changed there. Good sign. And we go down. Why is the what the heck? Why oh why? Why oh why is it not using all the rows? Clearly 16,000 here. Maybe I want to go the other way. Let's go up to the top and then open. Maybe I'm just not bad or good at copy pasting more, spending too much time in the database, not enough. Well, actually, probably better, but while since I've been on all those spreadsheet days, and that just didn't do anything. It's like my copy and pasting isn't actually applied to you. Oh, well, that would do it. Maybe I just need to copy to existing spreadsheet, recent, simulator base, insert. Okay, copy paste the entire sheet. Maybe I do need to build a data pipeline here. Oh my god. You kidding me? Server error complete? Okay. Let's just go into what do we got? What were we here? 11,240. 11,240. Let's go to A 11,240. Okay. It doesn't appear to be the same. It looks like there's definitely some week 5 data. A lot of week 5 data. Was I only doing this halfway through week 5? San Francisco versus LA? I was. Oh wow, so this is really missing data. That's only Thursday night. Okay. So I just need to then scroll up to everything past LA, San Francisco. Maybe then I'll just copy and paste that over, and then it won't be as annoying. Oh wait, there's 4. Week 4, week 4, week 4. Week 4, week 5. Why is this starting with Dallas, New Jersey? Is there a date I can filter this on? Game date. Yeah, we're just gonna quickly sort this by game date. When was that game date? Yeah, when was our game date here? 10/2. Okay. So we are just going to filter on all games and data that's after 10/2. We'll simulate a little incremental step here because it's being a huge pain in the butt. Filter by condition. Here we are. Let's go. Date is after exact date 2025 10/02. Okay. 4,000 rows. That's much better. Okay, great. Now we will go ahead and we're going to copy and paste all these. Hopefully this is actually enough. Data, at least, that it won't freak out. Copy. Fingers crossed. And paste. And why is it not pasting anything? Copy. This is why I don't miss Excel and why I don't miss working in freaking annoying browser-based spreadsheets. Are my hotkeys just not working? I'm just gonna crash this thing. All right, we're in. Cool. Great. Okay, so now we should go over to gold. Why is it skipping ahead to freaking... What? 41. And then it just decides to jump up? Why would it do that? Okay, whatever. We're just going to need to go through and manually drag all these formulas down, which is hilarious. Google Sheets. Google Sheets. Copy. And we'll add 3,000 more rows just in case. And what we're going to do. Paste. Okay. There we are. All the data is now populating. Woohoo! First and early, second and early, long. Okay, cool. All the game statistics looking good. These are mainly just two conversions and things. We're not expecting to see a ton of stuff in there. So I'm feeling pretty happy about everything. And it goes down to 60,000. Okay, we're in business. All right, so let us now download CSV. Now we can come over to our artifact. Moment of truth. Go away. And we can go over to our artifact. Upload. Our second one. Gold. Just double check this one's the bigger one. Whatever. And it's uploading processing. Good sign, good sign, good sign. Oh my goodness, it processed things. All right, who's playing tonight again? Pittsburgh? The away team. Ooh. Okay. Well, interesting. We'll see what happens when I do the simulation thing again. Pittsburgh. Cincy. That should be home team and away team. Pittsburgh is expected to win by 2.5. Let's simulate the game. Okay. Final score. Cincinnati 37, Pittsburgh 17. Those scores are looking much more applicable. Clearly they did cover the spread, so I don't think it, or Pittsburgh didn't, I guess. Oh yeah, because it is for team one. I see. Okay, that's fine. So yeah, and we got the drive log. Okay, so this is looking good. So Pittsburgh only had 53 plays, so Cincinnati was just dominating time of possession here. 254 yards, 228 yards rushing. That doesn't seem like Cincinnati. It's a little, no explosive plays. Ugh. Okay. Quarter one. 9 minutes. Incomplete. Oh my God. It doesn't know how football works. Oh, wow. Well, I guess we're ending it, but that is crazy. So it starts on second down, then goes to third, incomplete, then it goes to fourth, then it throws a pass. Oh my goodness. Not even close. Not even close. See, AI is not taking our jobs. We can still do everything right. We can still mess it up. Wow. And then, yeah, it's just never, we're always getting like 19 yards. First and 10, second and 10, third and 5. Okay, we'll try to maybe do like one iteration here. But this is nuts. This is nuts. Let's run 1,000 sims. Okay. Here it's saying Cincinnati wins 54% of the time and covers 66% of the time with an average score of 22 to 21. Probably not terrible. I don't know. That's still kind of terrifying. Average plays are a little low. Average drives are really low. But yeah, I mean, not surprised. Like the game engine doesn't even work. Wow. Just out of curiosity, I'm curious if I swap this to be Cincy Cleveland, what happens? Or Cincy Pittsburgh? See if it goes from 45 to 54. I just want to see if it's smart enough to understand home field a little bit. Shouldn't be super major, but usually home field, even today, is still worth a couple points. So I would expect Pittsburgh to be the favorite. Okay, it is. All right, so team 2 is considered the home team, and it does flip it. But yeah, these simulations are way off. Explosive plays are never getting rolled. Not enough drives, not enough plays. Because yeah, I mean, again, we simulate a single game, 37 to 1 here. Said let off the touchdown, but it's like starting at 2nd and 0. Like it's nuts. So we're just going to see what happens here. There seem to be some pretty significant flaws with how the game simulation is actually running. It looks like you have completely ignored kickoff rules because the game did not start with a kickoff. It also looks like you have no understanding over the correct sequence of how the game is played, despite being laid out in the spec. Drives always start at 1st and 10, and then it goes 1st down, 2nd down, 3rd down, 4th down, etc., unless the 1st down is met. So it seems like you have some potentially really severe issues, at least in like the sequence of how your downs are being calculated, which looks pretty alarming. Everything should be, in at least with timing, rounded to the nearest second and displayed in common time patterns when we're looking at things like the duration of a drive, how many seconds a play took, as well as the amount of time left in a quarter, etc. It's also not telling me how many. Oh, it does say touchdown, extra point, but it's not telling me, giving me like a running total of the score at the end of the drive. I'm sure there are more issues, but every time I run a simulation, could you also include a text file that dictates what formulas were ran and how a particular play call was decided and the outcome determined, just for visibility? Do not include it in the front end, but we just want to have that as traceability. I'm also noticing there are no explosive plays in the box score, which could just be due to some of the previous flawed game dynamics that I highlighted earlier. But yeah, worth pointing out. Go back over to Gemini. Hey, can you structure this feedback to be given to my developer? Yeah, cool. All right, we'll give it this and see what happens. But yeah, not a super 1, 2, 3, 4, 5, 6, 7, 8, 9. A super encouraging first step. So we'll see what happens here. I think I'll probably conclude the video if it's not able to get it right on this one, which I got to imagine it won't, but we'll see what happens. Still kind of cool though. Just out of curiosity, I'm going to do my Lions against Tampa Bay this week, just to see. Just to see. Ooh. Coin flip situation. Yeah, look at that. Average drive 7.2 for each. What's weird is the average score. This, I think, maybe it actually has some good news here. Is like, even though Detroit's only winning 46.6% of the time, the average score is 20.5, which kind of highlights their high end volatility. They could definitely put up a lot of points. So even though they have a higher average score, it doesn't necessarily mean they're going to win the game. So that actually gives me a little credence here. Rushing yards are just all these things. Rushing yards are so high. I mean, that should not be the case for Tampa Bay, realistically. Still no explosive plays. Average plays per game. I don't know. Let's who are the teams with the highest pace in the league? Who are the NFL teams with the fastest pace? New Orleans Saints and Miami Dolphins. So let's just out of curiosity, run one with the New Orleans Saints and the Miami Dolphins, just out of curiosity. Yeah, 60.2 and 59.4. So there's definitely some weirdness going on there. Let me do have another question. Which teams run the most plays per game in the NFL this year? Okay, the Giants and the Eagles. Okay, so let's actually do Giants and Eagles. That was actually kind of a fun one because they just played last week. So we'll go back here. New York Giants, Philadelphia Eagles. Yeah, 61-58. So there's something going on. Definitely some validations. Also, no one's kicking field goals. Are you serious here? Like, we're never kicking field goals? So I feel like there's definitely some weirdness going on. Definitely. So I don't know. We'll see what happens after it claims to fix the bugs. Alrighty. Let's see what happens. what I'll probably do if this doesn't continue to work is I'm just going to go through like the spec and I'm just going to individually ask it like the spec says to do this. Are you applying filters correctly? And effectively just like go through line by line. So again, just because this probably will be the last little segment here before I end the recording because like we've already gone over 2 hours. Oh my goodness. Um, but yeah, well, hopefully you find it interesting. Definitely going to get to chop it up with some little key moments or whatever so that you don't have to sit through a lot of the lull. And then yeah, but moral of the story, AI for coding can be super useful for prototyping, can get buy-in, prove the concepts, show kind of like the frameworks you want to use. Does not replace good requirements, does not replace good data cleaning. And even with those things done right, AI showed usefulness in helping us clean those up so that we have more cohesive, organized spec documents, etc. But even with all that, it clearly still has lots of room for misinterpretation, just like people do. So at the end of the day, it's probably going to be having a comprehensive step-by-step review saying, hey, let's pretend we're starting a game. Explain to me the code that kicks that off and how you're applying and determining what happens. And then just keep bringing hypothetical after hypothetical after hypothetical until we're actually able to get to the bottom of it and figure out why some of these issues are happening. Well, my guess is that there's just going to have a lot of situations where it just fell back to nonsense, or it didn't apply kind of like the average filters correctly to do like the scenario bucketing. So we'll see. But I hope to have maybe a much shorter video where I walk through some of my picks for the week using this product. And then maybe, yeah, just give a little bit of a summary of some of the steps I had to take to actually get it to work correctly. And then, yeah, we'll see what happens. So I can't even time my conclusions correctly. It's still working. Jeez. All right. Ooh, I think it's wrapping up. Oh, I crafted a bug report, and then it did some fixes, and now it's creating a reference guide. Interesting. Like a quick reference guide. Interesting. I wonder if it references its reference guides again. Maybe this is a situation where I actually take it into spin up a project and do a little Git repo. All right, so doing it all. I like its little emojis and stuff in here. It's always kind of funny. All right. So it's claiming that it's fixed. And then it's claiming it did this. It didn't start kickoffs. Yeah, hard coded. See, just doing a bunch of hard coding stuff. Like it was very explicit. You don't hard code. But anyway, so it created a helper. Okay, that's good. Field position dynamically calculated. Sounds like there's not going to be any fumbles in there, which isn't ideal, but maybe it'll happen. Down and distance logic fixed. Rebuild start new drive to explicitly initialize down equals 1 years ago 10. Rebuild advanced play with proper down detection. Fixed turnover on downs triggers with downs greater than 4. Perfect. Enhanced penalty handling to maintain property down distance, cool. Timing issues, fractional seconds, great. Does round. Running score, fixed. Awesome. Explosive plays, fixed. It was tracked but not highlighted. Well, okay, sure. Column now shows in bold orange font and a bunk. Okay. A little bit of an overcorrection, but whatever. And there's a traceability log. Cool. Documents, formulas used. Download button. Okay, so I can download the traceability log. That'll be useful. So that'll actually help speed things up a lot too. And then yeah, little verification checklist. Cool. Sample output. Cloud artifact. Did some validations. All right. Let's see what happens. Let's re-upload. Just out of curiosity, we're gonna use a different game. Let's see. What do I got? I'm in this little pick 'em thing every week. Pick the 5 games against the spread. What's our tightest one? Could be interesting. We have, okay, Indy, despite being one of the highest scoring offenses in the league and having the best record in the NFL, they are currently a 1.5 point underdog to the Los Angeles Chargers. Let's see what our app thinks of that. Oh, wow. I guess we'll wait. Oh, I hope it's not the. Oh, I should have only maybe done the output for one game. Continue to wait. Let's see what happens. Close out some of these unnecessary tabs. Let's see if we can speed her up a bit. Oh. What happened? Oh, so waiting. Well, another lesson. Can't always have things work the way you want. So I guess I'll probably just have to kill this page and go back and start over again. So yeah, we'll see. Hopefully the next video is a little bit better. I guess I'm just gonna have to exit the page. All right, until next time.